This is going to be used as an example problem from the physics resource book. This is for uniform circular motion. It's problem number 19. A children's carousel rotates 3 times every 2 seconds. The diameter of the carousel is 3 meters. What is the period of motion? What is the tangential velocity of the carousel? And what is the centripetal acceleration of the rider at the edge of the carousel? All right, so let's go through it first by doing what we always do. Let's list what we know. So we know it goes around 3 times. That's 3 cycles. And it takes 2 seconds to do that 3 times. That's 2 seconds. And that's not the period of motion or the frequency. That's just time to complete some task. That's why it's a little t, not a capital T for period. The diameter of the carousel is 3 meters. That's great. That means the radius is 1.5 meters. So that's kind of an obvious conversion for us. First question is, what is the period of motion? So my strategy is real simple. I'm just going to use the definition of period. And the definition of period is the time divided by the number of cycles. So that's easy. It'll be 2 seconds to go around 3 times. That's 2/3 of a second. If you're going to use a decimal, that's fine, but it'd be 0.6 repeating, and make sure you store all the decimals when you're using this for any calculations. So at this point, in order to answer any questions, I'm going to consider the period of motion to be one of my givens, because I don't have enough in the given side to figure it otherwise for circular motion. So 2/3 of a second is the period, and r is 1.5 meters, and I'm going to consider those my givens. So let's go on to the next question. What is the tangential velocity of the carousel? So my strategy is going to be kind of simple. I'm going to identify the equation with the radius, the period, and the tangential velocity, and then I'm just going to isolate VT and solve. So my list of equations that we have for uniform circular motion are these: the tangential velocity, the centripetal acceleration, centripetal acceleration, centripetal acceleration. So what I'm going to go through is I'm going to look for one equation that's got these three variables in it: the radius, the period of motion, and the tangential velocity. So I'm going to go ahead and just start from the right. The tangential velocity, it's in my list that's in the circle, so that's good. And the radius, that's in my list, and AC is not in my list, so that equation's useless. Let's go to the next one. Radius is in my list. Period of motion is in my list. Centripetal acceleration, not in my list. That's in this little circular box at the bottom. Useless equation. Okay, tangential velocity, that's in my list. Period of motion, that's in my list. Again, centripetal acceleration, it's not in my little box in the bottom, so it's not it. Now remember, the box comes from the givens and the variable I'm looking for. That's what makes up those variables. Hope the last equation does it. I've got the radius, I've got the period of motion, and I've got the tangential velocity. That's it. That's going to be the equation that I'm going to use to solve this question. All right, so the velocity is equal to the circumference divided by the time to go around the circumference once, which is the period of motion. So tangential velocity is equal to 2 pi r over t. So vt with my numbers, 2 pi times 1.5 divided by 2/3 of a second. And then doing a little bit of math, I get 14.1 meters per second. Awesome. Okay, so let's kind of move on and do the third question. What is the centripetal acceleration of the rider at the edge of the carousel? So at the edge of the carousel, my strategy is going to be kind of the same. I'm going to identify which one of my equations is going to have my three variables. I'm going to go back to my original givens, the radius and the period. I could use the tangential velocity if I kept all the decimals, but I'm not going to in case I made a calculation mistake. It's already scary enough that I'm using the period of motion that I calculated. I'm pretty confident in that one. And AC is my unknown. So those are my three equations I'm going to look for. So if I look at the first one, I've got the radius, and period of motion is in my list of givens I'm looking for, RT and A. That's not in my list. I'm looking for RT and A in this list. And then I've got the period of motion, I've got A, and I've got V, and that's not in my list. I'm looking for just RT and A, just RT and A. There's A, there's T, there's R. That's it. That's the equation I'm going to use. So I'm going to use that equation because it contains the variables that I'm given originally plus the unknown that I'm looking for. All right, so let's get busy. AC is equal to 4 pi squared r over t squared. So when I start doing some of the math, I'll put in the numbers. I'll put 1.5 for the radius. For the time, I'll put in 2/3 and square it. And I did a little bit of math to get the 9 pi squared times 1.5. So it's kind of not showing you the intermediate step there, which is out of order. It's right here, actually. 4 pi squared times 1.5 divided by 2/3 of a second. Do a little bit of math, and that gives me the 9 pi squared times 1.5. And the acceleration, 1.33 meters per second squared. Now, when I'm looking at this, I'm thinking, this is really not a children's carousel. 2/3 of a second to go around 3 times. The tangential velocity is 14.1 meters. That's like 30 miles per hour at the edge of this carousel. And the acceleration, 1.33 meters per second squared. If I divide that by 9.8, holy cow, that's over 13 G's on the outside of the carousel. So clearly it's mislabeled. It is not your typical children's carousel.